right, so yes, we're dealing with scientific theory, and I said a scientific theory is a powerful and broad explanation about the cause or causes of a broad range of related phenomena. And what I mean is quite simple. A theory is going to explain. A theory is going to explain all the scientific methods that has been put together. That's what a theory is going to do. All scientific methods that has been put together, a theory is going to explain that. So theories are established when a hypothesis is supported by convincing, repeatable evidence across many researchers or independent experiments. So what this means is that for the theory to be established, it has to go through other scientists, it has to go through other researchers, it has to go through other experiment has to be tested to prove this theory, okay, before it can be established. Now, what are the key characteristics of getting a theory or establishing a theory? The key characteristics of theory formulation. All right, so the key characteristics: organizational tool. Theories organize accumulated facts into a reasonable, logical, consistent body of knowledge, making information easier to retain and use. What this means is that with all the evidence that you've gotten, with all the observations, proof of knowledge, your experimentations, your hypotheses, your experimentations, you know, getting your conclusions and the likes. So with all that put together, what organization is that the theory is going to break down all what you've done and make it into a very wonderful information or a very short phrase that is easy to retain and use. All you need to do is just apply the theory. Applied theory. Okay, state the theory. So for instance, um, gravitational pull, all right, is a force. Gravitational pull is a general force. So the pull is going to bring anything under the gravitational force or anything under the earth, we undergo a gravitational force. And it is this gravitational force is a force that is being attracted towards the ends of the earth, meaning that it is gravity that is making us stand. It is gravity that is pulling everything down to the earth. That is the gravitational force. So gravitational force is a theory. It's something that has been tested by early scientists like Galileo and the likes. And now that it has been tested, it's a theory already. So instead of us um, beating about the bush or prevaricating about what and what not of the experiments that were done by early scientists like Galileo, early scientists, Newton, and the likes, you know, instead of us prevaricating about that, all we need to do is just take the theory that has been proven, the theory that has been established by all these scientists, that gravitation is a force or a pull that takes object or pulls object to the middle of the earth or to the center of the earth. So if you're in the earth, you're going to be experiencing that gravitational force. And so anything that goes up must come down. That's the rule of the earth. Okay, so that's the rule of the earth. So this is the organization tool that theory is talking about. That's the organization tool theory is talking about. So another characteristics of theory is that its broad application. A theory is formulated to indicate its range of application. What this means is that if main obstacles, let me put it, if main objectives are met, the theory is true. If main objectives are met, the theory is true. And this is broad application. So you don't really need to go through the scope of an experiment, or before you get a knowledge, you start going back to the experiment. Just like I said, we don't need to start experimenting and climb a cliff and fall down a cliff to know that there's gravity. We don't need dead bodies to know that there's gravity. We don't need all that. We already have a theory and we know something has already been established because it has been tested over and over again. That's what the theory is doing. And so the characteristics is broad application. We can now use that theory in other applications of other knowledge that we need. So if there's another field that we need to study, there's another field that we need to, you know, apply this theory to, we are free to apply this theory. That's what it means. All right, so that's broad application. That's a key characteristic. All right, that's a key characteristic. Then we have predictive value. Every good theory has predictive value. All right, so you can predict what will come out. It's a very, okay. Let's see this. There's some of us here doing business. There's some of us here doing management science. So let's look at this. Let's look at it this way. Mm, hey, for those of you doing business, Yemisi, is that her name? Yemisi.
Yes, Seventy is an name.
Okay. Uh, Yemisi, what? Okay, I already know you are doing MTH 10 for gift. You're doing MTH 101, right? Yemisi, what math course are you doing?
MPH 105.
Gift, is it the same you're doing MTH 105?
Yes, sir, it's the same.
It's the same. Man, okay. Uh, we need to have our own separate
Sir,
revision class during the week. Yes, during the week and
me, I'm
weekend
doing
as well.
MPH 107.
Mama, you are not doing any MTH. Okay,
I was just joking.
all right. So in mathematics now, um, we'll have separate classes during the week. We'll have to plan that because of your exam. All right. So now applications during the weekend on weekend like Saturday, we're also going to have that. Now, when I talk about applications, okay, for instance, we can use the knowledge for other things. We can use the knowledge for other things. We can use the knowledge for instance, we have a theory that if you keep money in the bank, obviously your purse gets fatter, right? Like your purse is going to be fatter. Don't be like us that we don't have business management or management science. People like us, we spend a lot, so we really don't put money in the bank. Okay, so as I was saying, mm, um, so as I was saying, um, we all know it's a theory that in order for you to grow your pause or make your pause fatter from every trade you can do, you should be keeping a certain percent in the bank or you should be storing a certain percent. And over time, your pause will be getting fat. And it's with this fat pause that you're keeping aside that you can be able to use to, give birth to other um, money, like use the money to work for you. That's invest. And then that money will want more money and they give birth to children and then great grandchildren because the money will keep on growing like that and expanding. Same thing. So um, that's a theory, right? And it's something that can be applicable. So instead of us to go and start testing, we already have the knowledge, we already have the theory to follow. And all we need to do is just use the broad application of that theory and apply it in our lives, and then we see the results. Okay? So that's what it means. Apply it in our lives, and we see the result. Now, the next key characteristic is a predictive value. Predictive value. Every good theory has predictive value, meaning that we can predict the value of that. Oh, I'm going to have a fat pause by the time if I keep on saving 100k every month. By the end of the year, I'm going to have like 1.2. You can predict because you know it's a theory. If I should mix, let's say I mix an acid and a base, I'm going to have salt. A salt will become you. It's a theory. It's a tested knowledge. All right. It's something that is going to come out, and we can have different compounds of salt, but you're going to have a salt. So you can predict because these are laws. Theories prove um, theories, they have a high degree of probability that are called natural laws, right? If you plant a seed in a loamy soil, it will grow. You plant it in a sandy soil, the seed will look at you. Simple. These natural laws also apply. If you're going into the philosophy of life, or if you're studying philosophy or studying, philosophy, they'll tell you about natural laws as well. If you go to the right environment, you will blossom. If you meet the right people, they'll they'll enable you to grow. You get more things. You develop more. You achieve more things if you meet the right people. And that is just the same thing with natural laws or theories. If you put yourself in the loamy soil, you will blossom. If you put yourself in the sandy soil, it will only be scorching, full of noise, and nothing is actually happening. Okay, so um, these are natural laws. Theories can be predictive. You can predict yourself or your outcome. You can predict it by the kind of people you meet. That's predictive. You can predict your account by how disciplined you are. I know I'm not financially disciplined because you can't be like that in this Lagos because ordinary 1 month if you're spending over 300k or 400k and you've not even spent on yourself. So I don't know how you guys do it or how people actually save. May God help us. But you see that predictive, I can predict myself that you know, or if I can be disciplined by the grace of God that touches my soul. If I can be disciplined, I can be able to predict a value of what I can expect at the end of a year or 6 months or 4 months. The same thing with predictive value of theories. Once you have a law or once there is a theory, you can predict anything and it will work. And that's why people can say, they can look at you and predict your future. They can actually do that because they are watching. According to psychology, they are watching the kind of people you mix with, they are watching your behavior, they are watching your style, the way you handle things and all that. Same thing with science. Science goes in almost all applications of life. Science is broad. Broad. Yeah. So theories have predictive values. Now, um, Um, so every good theory has predictive value, prophesying likely results with a stated degree of probability. Theories that prove universally um, valid and have a high degree of probability are called natural laws. So we should understand about natural laws. Say if you obey natural laws, just like a tree, a seed is put in the ground and then a tree grows. And even if there is a concrete that was you know, tiled on that part, the growth of the tree and the root of the tree will break the concrete, and the tree will keep on growing. Why? Because the tree is following natural law. Sun is beating it, the rain is falling. It has to grow. The nutrients of the soil and everything to suck it up, and it will grow. So even if you tiled the road with concrete, then the growth of the tree will break that concrete. The same thing with natural laws. Okay, so if you follow natural laws, if you follow natural laws, no matter the witches or wizard, your obedience will break the natural laws. It's just how it is. I mean, obedience to the laws. You get what I'm saying? Whether you're bad or evil or whatever, as long as you're doing those things, nothing can stop you. So it is predictive. Now, purpose. Theories enable scientists to explain, predict, and control phenomena and provide a new way of looking at familiar objects. Right? So theories enable scientists to you can use theories to explain, you can use theories to predict, to control events. When I say phenomena, I mean outcoming events and things like that. So you can use theories to do that. Theories enable scientists to explain, predict, and control phenomena and provide a new way of looking, okay, at familiar objects. So the way that you've been looking at it before, because of theory, you have a purpose of looking at that thing now, and you have a clear view of looking at that thing in a different manner, because now you have knowledge. Now there is knowledge. So, um, yeah. So now you have knowledge. Now, theories. Okay, I've talked about universal gravitation. I've talked about atomic theory before, where I said nothing can actually be broken down or split. But then we know that that theory has actually been dismissed because you remember it's your hypothesis or your theory can be overlooked. Another one can be proposed when we talk about the nuclear bomb, the atomic weapon, the nuclear energy, and stuff like that. Okay. So, theories of evolution. So the first We talked about scientific theory. The second thing we're going to be looking at in this course is the theories of evolution. And trust me, it's a whole lot of documents. A whole lot of
So,
documents. Yes, gift.
so if I have a question, please, sorry,
Mm-hmm.
sir.
Mm-hmm. What's your question?
I stepped, it's not really a question, sir.
Yeah,
I stepped out to get something. So I guess I've missed um predictive value.
Jesus. It's recorded. Oh. The class is recorded. All right. So I said,
You, where are you? See, wow. You said? You can go back and listen to it now.
all right, so I
Okay.
said predictive, the class is recorded, but predictive value, I said every theory has predictive value. Like you can be able to predict a result, you can be able to predict an outcome. If you're the type that is very disciplined, you can be able to predict your financial outcome in the next 6 months or 1 year or even 4 months. You can be able to do that. There's some people that no matter what, guy, they will save that thing. Me, no matter what, I will not save it. You get so because bills choke. You get so that's predictive value. You can be able to predict your outcome in the next year. You can be able to predict because you have a theory. There's a theory that states that every living thing will experience the gravitational pull of the earth. It's a theory. So we can predict that if I should hold a pencil and I stand at the top of a cliff, definitely the pencil is going to fall down. Theory. How do we know this? Because it has been tested already. It has gone through various other independent researchers, scientists, and experiments. So I can use theory to predict. Theory has a predictive value, right? You guys in business and management, you understand that if someone should follow a process for the next 2, 3 years or 4 years, the person will reach this height, the person will reach this height, depending on how disciplined the person is. Theory. You understand, according to psychology, you spend time with a person and you keep on spending time with a person. Very soon, with time, within 60, 90 days, a person gets used to you. Psychology. Theory. Why? All these things have been tested. In fact, the time you stop checking up on the person, now the person will be drawn to you to start checking up or checking you back. You get like checking up on you, what's wrong, because the person will miss your presence. Theory. Now, it's been studied over the years. It's things that people apply, psychology, different aspects of science, paranormal and the likes. There are theories that people have studied over the years and ages ago, and they've proposed this theory. Now, these theories, because of its predictive values, you can be able to predict something because you know that they have a high degree of probability. And these are what we call natural laws because definitely they're natural laws. They are things that cannot falter, no matter where it cannot falter. So it's a good thing that you guys are doing science. It's a good thing you're doing the business. It's a good thing you're doing management science. It's a good thing you're doing education, child development, and all that, because they're going. You, if you really study your course, you understand that there are deep insights, deep things that are really applicable to life that you need. And this is the fun part of schooling, not necessarily education, but schooling. Okay, so that's predictive value. And then theory have purpose. I said theory have purpose. The theories enable scientists to explain, predict, and control events. They control the outcome of events because of theories. Since these are natural laws, we can use them to explain, predict, and control events, which is what we call the phenomena. And we provide a new way of looking at things. So probably you were familiar with things, all right? The theory of optics, for example, changed the view of light. It changed how people look at light because now they were able to make the concave and convex lenses that was able to divert light, that was able to refract light into various angles and give us another view, give us a brighter view. People that have the myopia and the rest that can't see properly will be able to see. Long-sighted, short-sighted, and their visions were with time. you know, created. Now, all these things were studied, and then purpose came out. So now that there is purpose, now that there are laws, we can now apply these laws and have a new way of looking at things. So theory has purpose. This is another characteristics. And then there are various examples of the theories. Like I talked about the universal gravitation, atomic theory, relativity theory, and the theory of evolution by natural selection, which we're going to be discussing in the next slide, because theory of evolution, that's what we're going to be looking at. And yes, so now to the theories of evolution. Any question under that part? Any
I
question
don't
on?
have a question.
Okay. Any gift? Uh, yeah,
Yes,
you see.
sir.
You have a
Sir?
question?
No, sir.
No, 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 no
Okay.
question.
All right. So, um, now theories of evolution. Any still outside? Any, are you safe?
Yeah, I mean,
Oh, okay. All right. Theories of evolution. Now, let's move over to Darwin. Okay, now it's a lot. It's a lot of information. Darwin talked about a lot, but I'm not going to be boring you guys with the whole chunk of information here. I'll just go straight to the point. Now, early explanations for the variety of life. When we talk about evolution, we talk about how the human species came about. Now, there are various scientists that talked about evolution that we um, originated from the Homo erectus, the Homo sapiens, Homo erectus, from Homo erectus to Homo sapiens being the most intelligent aspect. That means we were formerly apes. And when you compare the human anatomy, you compare that, you compare the anthropology of the human species with that of apes, you see a little bit of familiarity, only that these other animals cannot construct proper language system, and that's what differentiates us. We can use language, they can't. Well, let me say they can use their own animal language though. Yeah, that's a point. That's a point. But we are able to communicate. We are able to study. We are able to. They have a little bit of intelligence as well. They're intelligent creatures. The chimpanzees, baboons, the apes, gorillas, and the likes. They're very intelligent. Yes, they're intelligent creatures, but not as intelligent as us. So there are theories that states that we came out from the apes. We were born as a new species, and then we started separating ourselves from these apes. We separated ourselves from the apes. So we were born as a new species. Do you understand? That's it. So we started separating ourselves from apes, and that's how we grew to be human. So from the Homo erectus to the Homo sapiens. Homo erectus, they were a little bit bent, all right? Homo sapiens, now we can stand tall. We can use our brain, we can think wide. All right, so now the evolution before Darwin. Evolution actually talks about the variety of life. Now, the first thing or the first point from the evolution before Darwin, let's not talk about all the information there. Let's just go straight. Spontaneous generation. The ancient belief that organisms originated spontaneously from non-living matter. I'm sure you guys studied this when you were doing biology, your SS3 second term. Yeah, you see all these things there. They'll be telling you guys about evolution, and you'll be reading about how non-living matter started producing bacteria, and from there, living things started to come outside. I'm sure you studied about unicellular organisms, and they believe that these things, with time, started taking shapes and forming complex organs, and then the humans were formed, which I feel is a very crazy belief. All right, so the spontaneous generation, I never actually approved of this belief, though. I read it in biology then. that year. So the ancients believed that organisms originated spontaneously from non-living matter, but this was disproved by Louis Pasteur in 1862. Take note of that, please. Um, in 1862, Louis Pasteur disproved of it. This is the first paragraph under 3.11, evolution before Darwin. Under 3.11, you'll see that in page 29. So I didn't, I just took the main points there. All right. The second thing is that doctrine of fixed species. Doctrine of fixed species is what we talk about the creationism. Now, the belief that prevalent in the Judeo-Christian culture and early science, John Ray, that each species was created by God and has remained unchanged. So some of you might be thinking that science does not involve God. Well, it does. So, doctrine of fixed species, creationism, like when you're hearing the Judeo-Christian culture and early science, okay? So okay, yes, the scientists also study metaphysics and study God, study the supreme being. So there is a part of knowledge or a part of science known as faith. They call it
That's
they call the
important.
knowledge faith. Yes,
You said that science also believe in God, right?
they study God. Yes.
They study God, so just but back then in school, science students does not do CRS because they do say that science does not believe in God.
I actually have research studies in Christianity and Islam. Are you going to say because I didn't do CRS when I was in secondary school, I don't believe in God?
No.
Okay, I think you've answered your question, right? Right.
Yeah, yeah, yeah.
All right, so they study God as well. They have research on God. They've gotten to they've gotten to study God properly. Okay. So, um, yes, doctrine of fixed species, creationism. So there is a part in science that's known as faith. This is the part that cannot really explain things. You know, um, they just call it faith. They call it faith. This is also in philosophy, where you cannot debate. You just call it faith because it has been proven according to the works of Christ, Jesus, and the rest, according to science, scientifically proven that Jesus Christ walked the earth. So that means things were actually created. If Jesus Christ really walked the earth and the document of Jesus being crucified is in Rome, they have the document of his crucifixion. They have um, these. They have the tomb. They have things that where he actually walked and where he actually stayed and all that is still recorded in history. If history has told us that he walked the earth, then faith exists. The reason is because there were lots of things that science could not explain. For instance, how did the world come about? They all use the Big Bang theory, but they are really not sure. For instance, how did the dead come back to life? They could not really explain that. How how the water turned to wine. They call it faith. They just call it faith. When you can't really explain one thing in philosophy, that is called faith study. You just categorize it under faith, so no one can debate that because it's above the human comprehension. All right, so this doctrine of fixed species. Now, evolution before Darwin, that's what we're studying now. Doctrine of fixed species, which is known as creationism, the belief prevalent in the Judeo-Christian culture and early science that each species was created by God and has remained unchanged. So now, out of the evolution before Darwin, we have events that revive discussion on evolution. For instance, we have the discovery of many more kinds of organisms. your unicellular organisms, the amoeba, the paramecium, those unicellular organisms, chlamydomonas and the likes. I'm sure you guys did that. You were reciting that in school. So we have that, the discovery of many more kinds of organisms. The study of fossils. When we talk about fossils, we mean things that have actually been buried for a long time, things that decayed matter that are stayed for quite a long time. So the study of fossils by George Cuvier, who proposed um, catastrophism. Catastrophism about what am I going to say, about matter, about things that have actually been buried for a long time. So that's what fossils is. Catastrophism. Rock layers held different ordered fossils due to dramatic ancient changes. That means as time goes by, things were evolving, just like the oil. We believe about carbonation, and these rocks, with time, started with time and heat, they started to change. They went through ancient changes and they developed these fossils formed rocks. And these rocks, that's dead matter, it formed rocks, organic organic matter formed rocks, and these rocks with ancient time passed through changes and they started to produce crude. Crude means something that is very old. Just so you know, crude oil, that's something ancient, old oil. So crude, it means it has been in the ground for quite a long time. And then before you know, this rock will just start to burst. And when the rock bursts, what comes out? Oil. That's a process of carbonation, and it's something we can discuss for another time. But so yeah, something we can discuss for another time, but not now. Okay. So that by um, George Cuvier. Another thing we should study here, just understand that during Darwin's time, biology was dominated by natural theology. Okay, that's what I talked about, God creating things. Biology then was dominated by natural theology, so people could not really debate how we came about. You understand? They just can't. All right. So now the third thing in the discussion of evolution is the George Lewis. All right. The Buffon's observations that all mammals share common features, suggesting evolution from a common ancestors. So ancestor, what this is saying is that all mammals, you know what mammals are, right? They all share common features. If you're going to tell us that we all share common features, that means we share the same feature. We have a common feature with the dolphins because they are mammals. With the yeah, they're mammals. With the wild animals, they are also mammals. With the chimpanzees, we have common features with them, and this is suggesting that all mammals, including us, we are also mammals. It's just that we're higher class. Um, we all come from a common ancestor. This is George Louis Comte de Buffon's observation. All right, just in case you're asked, take note of that. Yeah, you see, no, not 1809, not 1809. I'm just trying to check that page where I got that from. Okay, so George Louis Comte de Buffon's observations. Then we have James Hutton's. James Hutton's hypothesis of gradualism. What this means is it is suggesting that sedimentary rocks formed slowly, implying the Earth was millions of years old, not thousands. Millions of years old. The reason, sedimentary rocks are gotten from debris. When I say debris, dust particles, water particles, mud, rocks, different dirt. Let's just call it dirt. Dirts coming together to form a rock. And before you know, they are going to form a gigantic rock. That is sedimentary. Okay, so this was James Hutton's hypothesis of gradualism. James Hutton's hypothesis of gradualism, suggesting sedimentary rocks formed slowly, implying the Earth was millions of years old, not thousands. So the Earth was millions of years old according to your unit, not thousands of years old. Millions of years old, not thousands. I'm actually checking where I saw. Mhm. And the next one, okay, so this was James Hutton's. And the next one is Jean-Baptiste de Lamarck's. And Jean-Baptiste de Lamarck's unified theory of evolution was based on the inheritance of acquired characteristics. Now, this one was actually this one was quite studied also in biology. He proposed that changes acquired during an individual's life were passed to offspring. That is quite that is quite correct. Changes acquired during an individual's life were passed to offspring. But this mechanism was later proven wrong. For instance, a giraffe stretching its neck. Now, when I read this in biology, I was like, because if you study how he thought about giraffe, he thought about the animals were just normal, and then they kept on stretching their neck and stretching their neck, and when they give birth, they taught the others to stretch their neck and stretch their neck. Like when you study all these things, you wonder how were these people called scientists? How can you tell me that because an animal is stretching their neck or stretching its neck profusely for a long amount of time, then it will turn out to be a giraffe. And then automatically, when giraffes start giving birth, they give birth to long-necked animals because their ancestors were stretching their neck. How? Well, that's why it was
That
proven.
means, sorry, sir. That means if our ancestors too were also stretching their neck, that means us too, we are also going to be stretching our neck.
s-
Welcome to job.
Something like that. Or we'll have long necks. Yeah.
That's funny.
Or have long necks. So this was Jean-Baptiste de Lamarck's unified theory of evolution. Crazy theory that evolution was based on the inheritance of acquired characteristics. To some extent, it's true because some people they acquire characteristics from their parents. Some people will just say, "Oh, that is my son. He's just like me. That is my son. That is my son." That's what they just keep on saying. So this is Jean Baptiste. You'll find this in page 31 of your course. That is my son. When he proposed this, and he also proposed that all species, including human beings, were descended from other species. I've talked about that before, and probably we were given birth to by apes, and then we became different, and so we stood aside. You know, even people that studied Christian etymology and the biblical etymology, they agreed with that evolution that God created animals first and then he created man, meaning that God works with a process. So he used the process, and it was apes that just gave birth to a human species. And man, I beg I tire for all those scientists. Anyways, now that we have the events that um, revive discussion on evolution, these are events that revived discussion on evolution. All right. These are events that revive the discussion of evolution. Now we move over to
13 after.
Darwin and
13
modern
after.
evolutionary thought. Hot mic, hot mic. Now we move over to hot mic. We move over to Darwin and modern evolutionary thought. Charles Robert Darwin. He provided the first scientific explanation for the diversity of life based on his observations during the voyage. Okay, so what happens is that fossils and living organisms. He talked about, he proposed fossils and living organisms. All right. He said that I'm going to explain what those things, what they mean. Glyptodonts and armadillos. That's what he said. That's what he used. He said extinct giant glyptodonts. I'm sure you don't know what glyptodonts are, um, which we're going to discuss. And then he said living armadillos. He said that he noticed that the extinct giants closely resembled the living armadillos. And so, what are glyptodonts and what are armadillos? We actually studied this also in biology in school, but let me see. Mm, So, glyptodonts are just like dinosaurs. Mm, Let me see. They're just like dinosaurs, all right? It's a type of um. Let me see. I want to show you guys a picture of an armadillo. Okay, I've seen a picture. All right, so this is one picture of armadillo. I'm going to send it to the group, so just check it out. That's an armadillo. Now, I want you to compare this with. Okay, I want you to compare
I
this. Hold on,
haven't seen
hold on,
anything
hold
yet.
on, hold on, hold on. Calm down. Blood to the earth. Relax. I want you to compare this with this. Second. Mm, okay. All right. So compare and tell me what you think. Then we'll be able to discuss Darwin's properly. Compare and tell me what you think.
So if you want the first one I sent,
Just compare first. Forget the first one I sent. Compare it. What do you think?
they're not the same thing. They don't look alike.
Come on.
Their back, or what I call it, their shell, or what it is, it, it's it's different.
It's different, of course, but it's quite similar at the same time. Who else is seeing the
Yes,
Who else is seeing the image, please?
the neck
Okay, what I see
is
there, the
longer.
neck, for the first one, the neck is not the same thing with this other one. This other one is just someone like this, it's what, and that's tortoise, but it's not tortoise. The
Okay.
neck is not the same thing. And the skin color, the skin
Yeah.
wants to look alike. Yeah.
And I think
And this other
the back,
one has this first one, this other one is like a tortoise, but it's not a tortoise. And this one is someone like
rat,
the neck
abi.
shape is somehow. The neck looks somehow.
So
And their
the mouth,
tail, their, the tail is different. This first one has the tail is different from this other one tail too. The only thing that is similar there is just the skin. That's the only thing that is similar because the head of this first one is big The head of the second one is tiny. The devil's one is tiny. So that's for the first image. The
Okay.
And the
second
mouth is big.
image, the second image, I guess is better. They're the same thing.
Now, the thing is,
Have you?
yes, they are quite different. The first one is the Armadillos. Now, the second one is the giant Glyptodonts. Now, the Glyptodonts were known to be dinosaurs. You know, in the extinct ages, dinosaurs existed.
Yes.
Okay, so now that one, they are dinosaurs. So later on, they are saying that the family of those dinosaurs birthed various other things that looks like the Glyptodonts, and those things were the Armadillos. If you compare them, they quite look similar. They have almost the same shape. One is bigger, yes. One is gigantic, yes. One is gigantic. The other one is small, but they have almost the same shape. Their shape is quite similar, and the way they actually walk and move is quite similar. So you might be looking at it and be saying that, oh, this is an evolution of the dinosaurs we have before. Just like the way they compare chicken with their bipedal stance, or birds with their bipedal stance. They compared them to some dinosaurs because they looked like those dinosaurs. And then they're asking that, is it that these are the descendants, or of the former one? So that's why Darwin's clues were that fossils, when I say fossils, I mean decayed organic matter that has stayed for quite a long time. Now, fossils and living organisms, he noticed the extinct giant Glyptodonts closely resembled the living armadillos, and it led him to wonder if the latter, that means if armadillos, were descendants of the former Glyptodonts. You see that? Even Annie had to use binoculars to check very well because
I swear.
she's wondering, what is this? All right. So the second thing on Darwin's clue is geographic variation. The second thing, he observed that similar organisms like the island tortoise showed remarkable differences based on the island they lived on, suggesting that this descent from a common ancestor followed by modification. And I'm going to explain this. What this means is that um, for different environments, they might be the same species, but for different environment, the environment changed them with time. Geographic variation is that the environment changes the species with time, and then the species starts giving birth to that new species because of the environment. All right, so there's this geographic variation that everybody span out from Africa, and they all came out from the root. And if you check the DNA of all living things, I mean human beings, they have almost the same DNA as your melanin DNA. There are two things that are potent, and it all traced back to Africa. So it means that we are the Mother Earth. So if you are black, be proud of yourself. Like just kiss yourself. Mwah. So it means that we are the Mother Earth, and we have the original DNA to the Earth. So how then do we have white people? How do we explain this? I'm not talking about albinism. How do we explain this? According to evolution, the geographic variation here is explaining that as people migrated due to the weather, time, space, region, temperature, it changed the outcome of the people. They were all similar at the same time. We all had almost likely the same DNA as blacks. And if you study the beginning of humankind, you understand that all human beings originated from the black Africa. All human beings. The same Africa they treat like trash, yes. Your Africa, yes, yes. So now, You
Sorry,
observed.
sir. You
Yeah.
said, sorry, sir. You said all human beings, like all those white people too, they're also from African.
And it's the evolution I'm
Ah,
trying to
sorry,
explain.
African.
It's the evolution I'm trying to explain.
Okay.
Yes, all living beings originated from Africa. All living beings. Because the black people have the original DNA of the Mother Earth. So it is rooted. And I'm not speaking of something that is one-sided. I'm speaking science here. Something that has been tested, proven, recorded. So you can do your research, you still get the same answer. So the thing is, when people moved, when they migrated, the region, the temperature, the weather, due to geographic variation, changed them. And you notice that those in the Asian part of the world, you know why they say the Chinese eyes are like that? Because they grew to, the weather changed their skin. They grew to always be closing their eyes. So they believe that with time, with time, they developed small eyes because of the kind of country they are from or the kind of place that they found themselves. With time, they kept on closing eyes and closing eyes and closing eyes. And before you know, that's just how their eyes are. And when they give birth, the child automatically just is just like that. Ah, you see that?
Like you mean the example on the Chinese, Koreans, and so on. That's the way they've been doing their eyes, like their forefathers,
Yes, the forefathers.
right?
I mean, according to evolution, the f- the set of people that moved there with time and time and time and time over again, their eyes has always been like that, short, small. They always kind of close it and close it, and so it just happened that everybody started using that same eye. That's once you're there, they just use it. All everybody around them are using the same range of how you're going to open your eye. Evolution explains that with years and generations and thousands of years that pass by, it just happened that they developed that kind of face. And when they give birth, automatically, the genetic change or the geographic variation of similar organisms that were like us had to change genetically due to the environment. Their hair changed, DNA on the hair changed, DNA on the skin changed, their melanin reduced because now in Africa we have high melanin. Melanin is actually the pigment that gives us the color on our skin. Melanin is the hormone that actually um, fights, sicknesses. Melanin, when contacted with sun, stores in sun energy, which is soul, making us darker, or it brightens the melanin more. And when that happens, it generates other hormones that cure sicknesses as well. Um, so when you stay under the sun as black people, you're not only suffering, but at the same time, you're also receiving energy. The sun actually feeds the blacks, you get. So now we have the high tendency of melanin. Melanin reacts with the brain producing more cortisols and hormones that make the brain more effective and sharper. So melanin increases intelligence. It's just that we use our own intelligence for greed and corruption, you get. So that's why we're where we are. But if you check it properly, Africans are one of the most intelligent people. Now, hey, gifts and Pearl, calm down. Now,
I wanted to say that we also use our intelligence to dance.
well,
Because we like dancing.
well, well, the thing is, scientifically, according to science, the DNA structure is made up of sound. The DNA structure is made up of sound. Your very DNA is made up of sound. And guess what? The people that have the highest melanin, their DNA vibrates. So when the human body reacts with sound, that's why they say God loves music. The human body. Okay, it vibrates with sound energy. One can please you, one can irritate you. Now, the people that have the deepest roots to the soil, which are the Africans, have the greatest DNA. Have you ever noticed that when they're playing some kind of songs, your body will just start moving?
Yeah.
There are some times when they're just playing some certain songs, you don't want to move, but your body will just start moving. It's because the song or the sound is resonating with the DNA, your own very DNA in your cells. You just have to vibrate because that's like that's ancestral spirit. It's communicating with your DNA. It's in one. I'm speaking pure science. Okay. I'm not going outside the box of science. It is science. All what I'm saying is proven fact. So the sound actually vibrates with your DNA. Same thing. Um, the melanin also tones in with the DNA. And for melanin, the higher the melanin, the more effective the DNA. And we have more melanin. And so we are prone to laughter, entertainment, sound, music, and things that make the body vibrate. That energy is inside of the people with more melanin, the people that trap the sun and use it to glow. The more sun you trap, the darker you become. So um, you're like the radiance of the sun. The darker you are, the more sun you've trapped. You're like the radiance of the sun. So it shows how high your melanin is. Get what I'm saying? And those are the people that vibrate. The blacks, they vibrate. So that's why you find most of us, it's in our genes. You just notice that Africans automatically are intelligent and Africans are entertainers. Oh, when it comes to entertaining, we can sing, we can dance, we can party. Come on, name it. You'll find us there. You feel me? Hell, why are you why are you vibrating like this? All right.
I'm not the carry last.
Yeah. That's why we are where we are. The entertainment has got into our head, eh? Okay, so geographic variation. So with things that are going to move, all right, you know, there will be modification. All right, so that's what this geographic variation is talking about. These are Darwin's clues. Now, the mechanism of natural selection. Darwin was influenced by Malthus' essay on population, which stated that populations tend to outgrow their resources and must compete. Is another part. This is under the mechanism. The mechanism, it says natural selection. Populations tend to outgrow their resources and must compete. So, because we tend to outgrow our resources, but let us be aware that Nigeria, we've not outgrown our resources. If we were actually, um, if we were actually meant to, it's just that it's a condition. They have to put us in this condition so they can retain power. Politics. But if we're actually meant to go by our resources, Nigerians can sit at home and get paid on a weekly basis, and we will not get broke for the next 2 centuries or three or four. We won't be broke. Like every citizen can get paid if we were to measure our natural resources. There are resources that they are not mentioning that are being mined by the Chinese, the Europeans. There are resources that we have that are being mined and that are being utilized by other countries. But guess what? Our politicians will sell these resources all in the name of insecurity in the north. People will come there and be mining and they'll be doing insecurity. So people can't farm, people can't do anything, but they are mining. Let me not even start with the country, sha. So, now what Darwin is trying to say is that we can outgrow our resources. And if we outgrow our resources, what happens? We start to compete. We start to fight for land. We start to fight for how we're going to feed ourselves. We start fighting for crazy things because we've outgrown our resources, or we migrate, or we move. In the struggle for existence, which is competitions, individuals with advantageous traits, like people that have superior physical or behavioral attributes, are more likely to survive and reproduce. That's how it is then. You know, and it's actually like that now. The richer guy gets the fine lady, the richer guy gets to, you know, the rich woman gets to dictate and control. Do you understand? So it's just like that. You compete. And because you have the advantageous traits, they are the ones that will reproduce, they're the ones that will survive. Even the Bible states this, and the rich shall become richer and the poor poorer. You get what I'm saying? So they're the ones that will likely are likely to survive and to reproduce. So nature selects the fit and eliminates the unfit. Now these are all mechanisms of natural selection. So if you're fit, you're ready to compete, you're good to go, nature selects you because, oh yes, you're good to nature. And then it eliminates the unfit. The useful traits are passed to offspring, leading to gradual modification and eventually prevalence of favored individuals. So this process is what we call evolution by natural selection. Evolution by natural selection. And before you know, you have a nation full of champions. You have a nation full of, because the unfit are being eliminated. The ones that survived are the strong ones. They survived and they reproduced, which they're going to train the next generation on how to, you know, be like that. So Darwin was influenced by Thomas Malthus' essay on this, and Alfred Russel Wallace independently reached the same conclusion about these aspects of natural selection. This is under Darwin and modern evolutionary thought. Now let's now check about evolution after Darwin. Okay, let's check about evolution after Darwin. Um, yeah, where is that page? Let me see. Evolution after Darwin. Before Darwin's death in 1882, even after his death, many important discoveries have been made, and these have led to better understanding of the mechanism of evolution, natural selection. These discoveries were made in other fields of inquiry, such as paleontology, genetics, biochemistry, embryology, geology, ecology, audiology, and we'll be learning about this. Okay, so Darwin, before his death, predicted that fossil record should yield immediate links between great groups of organisms. When I say fossils, what do I mean? I mean dead matter that has existed millions of years ago. Fossils. Please try and remember what that means. So if we're using the word fossil, you understand what it means. Okay? Now, let's talk about the paleontology. Paleontology, the discovery of immediate links, such as a bird reptile that was known as the Archaeopteryx. Now, the Archaeopteryx confirmed Darwin's prediction and extended the known theory. Please know the spelling of those things. So I think I dropped them in the summary. Paleontology, under paleontology, um, the
Yes.
yeah, Archaeopteryx. You see there. Let me see. Where is it? Where is it? Where is it? Okay, yes. All right, yes, it's there. So a bird reptile confirmed Darwin's prediction and extended the known history of life back over 3.5 billion years. All these bones and all these, let me show you this reptile. So you see this reptile. We're talking about all these things existed. Like, when they check the bones, the fossils, when they check it and they investigate, they're like, wow, okay, so this thing actually existed. This bone is old, as in up to 3.5 billion years. Archaeopteryx, ancient wing, that's what they call it. It's a type of dinosaur Uh, Let me see. Let me show you. So this is the dinosaur. They only found the bones, so they could not really get the full image of the dinosaur. So from the bones, they just put two and two together, and they were able to bring about how this dinosaur looked like. Hmm.
The network is really bad though.
Whose whose network?
Mine,
Can you hear me?
the the voice is like it's coming and going.
Okay. Uh, Not on my records though. Not on my record, but the recording will be clear. Don't worry. Um, do we have this? Can you see the archipteryx?
Yes, sir.
All right. So this bird or bird reptile, it confirmed Darwin's prediction and extended the known history of life back to over 3.5 billion years. That means this Earth has been on for billions of years. Now, genetics. Under the discoveries of other fields, that's evolution after Darwin died. Genetics, can you mute?
Oh, sorry.
All right. The genetics, the rediscovery of Mendel's law of inheritance. Okay, the rediscovery of Mendel's law of inheritance. The rediscovery of Mendel's law of inheritance solved the crucial test that worried Darwin by explaining the mechanism of heredity, how variations originate and are passed from parents to offspring. So, you see, first of all, Darwin was geographic variation, but this time around, someone was also able, Gregor Mendel was able to talk about the law of inheritance, also a theory, the law of inheritance telling us that we can take hereditary or take traits from parents. All right. So it's a crucial test that worried Darwin, and it worried Darwin by explaining the mechanism of hereditary, how variations originate and are passed from parents to offspring. So passing on traits. Okay. And then we also have the last part, which is the biochemistry that came out after Darwin, talking about the comparing amino acid sequence and proteins from different organisms to provide a good measure of their degree of evolutionary relationship. So, modern research confirms that natural selection is still operating in humans. When I say natural selection, it is selecting the fit and eliminating the unfit. This is natural selection. You're too sick for this part, or you're too, before you know, you're off. They call it evolution. Or this person just can't survive it. They call it, in science, they just call it evolution. Natural selection doesn't want you in this environment. You guys can remember when the British, um, they're already used to their own environment and all that. When they came to the walls of Benin and they wanted to take over, and they were dying, not by anything, but by malaria. Africans were there, but natural selection destroyed the British people. They were dying. While while you see the African men moving and the women that used to guard the states, then women were the warriors. The women were alive and people were well and stuff like that. The British people were dying. Natural selection. Nature in that part then selected the fit and eliminated the unfit. So they had to bring about tea, bring about some other things. Then they brought cannons and they bombarded the walls, destroyed it for weeks before they were able to get in, to take over the Benin. Okay. Uh, so yeah. So the key points. What are the key points? Let's take the key points under this. Let me see. All right, so the key points. Theory definition. All right, so that's the first thing, the first key, theory definition and explanation about the causes of a broad range of related phenomena. That's theory. Then we talked about theory origin. Starts as a hypothesis and is confirmed by convincing independent evidence. And then theory value. Theory has predictive value and enables us to explain, predict, and control phenomena. And pre-Darwin theories. Pre-Darwin theory, that's before Darwin, spontaneous generation, and doctrine of fixed species, which is known as creationism. The one I told you guys that God created living things according to Judeo-Christian belief. And then spontaneous generation, you remember what that means? That spontaneous generation is an ancient belief that organisms originated spontaneously from non-living matter, which was disproved by Louis Pasteur in 1862. Please take note. And then we also talked about um, the revival events that brought about the discussion of evolution, discovery of more organisms, fossil studies, Cuvier and catastrophism, Buffon's common mammalian features, and Hutton's gradualism of ancient Earth. Please go back to the revival and um, the revival of those discussion. We said that the discovery of many kinds of organisms in the 18th century birthed about the study of evolution. The study of fossils by George Cuvier, who proposed catastrophism, that rock layers held different chronologically ordered fossils due to dramatic ancient changes. So there were fossils that were in those rocks due to dramatic ancient changes. One question is, all these fossils are now producing a lot of resources. Could it be that these dinosaurs were in Africa mostly? Guy, what's wrong? Why is it our continent? Then Judges Lewis counted the Buffon's observations that all mammals share common features, suggesting evolution from a common ancestor. That means we all have a common ancestor, which I said scientifically proven that all DNA can be traced to two potent DNAs, that we all came from a man and woman, blah blah blah, those kind of things. Then we have James Hutton's hypothesis of gradualism, suggesting sedimentary rocks formed slowly, implying the Earth was millions of years old. Then we have Jean-Baptiste de Lamarck's unified theory of evolution. Based on the inheritance of acquired characteristics, he proposed that changes acquired during an individual's life were passed to offspring. For example, a giraffe stretching its neck, but this mechanism was later proven wrong. This giraffe stretching his neck is Jean-Baptiste de Lamarck's. Jean-Baptiste de Lamarck. Please remember who made about this giraffe stretching his neck. Know his name in your sleep. All right, so um, Lamarck's error was proven wrong. Then we talked about Darwin's clues, resemblance between armadillos and fossil Glyptodonts, and geographical variation in species, okay, like the Galapagos tortoise. We also talked about Malthus' influence, his essay on population, that competition due to limited resources provided Darwin the clue for the mechanism, which is now known as natural selection, the mechanism where nature selects individuals with advantageous traits to survive and reproduce, leading to evolutionary modification of the species over time. And Alfred Russel Wallace co-proposed this, meaning that the whites could not stay here because they are already used to their terrain, and if they stay here, they just keep on dying like flies. Meanwhile, the blacks here were good. They were able to reproduce because they were strong. They were not getting sick. The mosquitoes didn't mean anything to them. I wonder why now mosquito affects us. But anyways, then we talk about the post-Darwin evidence. Paleontology confirmed immediate intermediate links, like just like the archaeopteryx. We talked about genetics, Mendel's law, explained the mechanism of hereditary passing on traits, post-Darwin evidence. Remember, all these are post-Darwin's evidence, like after Darwin, after the death of Darwin. That's post-Darwin's evidence. Paleontology, genetics, and biochemistry, which compares amino acid sequences to measure evolutionary relationships. And then we have 20 questions from this unit. 20 questions from Unit 3, which I am going to drop for you to make your research and study more. Question.
Hey, sir, the other time you said you don't know why we are having malaria now. The mosquito is biting because we are not strong as before anymore. That's why you're having malaria.
No, as in, I don't know why we're falling sick. Any little thing now we're sick. I don't get it. Well, me, it has been long. I felt sick though. It has been like years already. Last time,
Maybe
I've not even visited the hospital in quite a long time.
our body tries to tell us that we are also a human being, so we can fall sick. So that's why.
Not like the whites. Not like the whites. All right, so I'm giving you those questions. Go over those questions and study them. Let me see. Do you have any question so far? Let me see.
Ah,
Okay, so
let me see that,
I'm
please.
stopping the record now, and I will upload it later.